Hey, hi everyone. Today I thought of to create a video on one very interesting topic, which is the idempotent keys. Why I thought of to create a video on this topic is because the solution this concept provides us is very general, and every software engineer as well as non-software engineer folks like the product manager, program managers, and other folks also, they should be understanding the concept uh, where exactly we use the idempotent keys. So the problem statement is very general and it used everywhere. Okay, enough context. So maybe I can start with the problem statement now, and then we'll discuss about how exactly idempotent keys fix the problem. So what happens is, for example, you have bought something on any website, maybe it's Amazon or something else, and you just uh, want to pay for the items you have bought, right? And what happens is you just click on the pay button, and for example, your card value is 100 rupees, and then you make a payment of 100 rupees, and then you click on the pay button. So what happens next is that you make a request to the pay, you make a request to the server to deduct the 100 rupees from your account. And what happens is server receives the request and initiate the transaction and deduct the 100 rupees from your account, and then send the response back to the client. When I say to the client, it is you. So what happens in between is that maybe the network is down, or maybe there are some other reasons as well, that due to which client is not able to get the response back from the server, and thinking that your payment was not successful, you again retry the payment, right? You again click on the pay button, and server again gets a new request and consider that it's a fresh request, and it deduct the 100 rupees again from the server, from your bank account, and sends the response back to you. So if you face the network issues, or you face the issues to get the response back from the server, you keep retrying it, and every time you retry, server consider that request as the fresh request, and it keep deducting the amount from your bank account. So this this implementation at the server is not cannot be considered as a good implementation, is because client is thinking that the payment was not processed at the server, and keep retrying it, and server always was getting that request and consider that request as the fresh one, and keep deducting the amount from your bank account, resulting that every request succeeded, but client was not able to get the response back, and your bank account was, the amount from your bank account was getting deducted again and again. Okay, that's where the idempotent keys comes into the picture. So what happens is, I'll take one example to make you understand how exactly these idempotent keys works actually. So I'll take the same example. So you have bought something, and then you just trying to make a payment to the server. What happens at the client side is, whenever you click on the pay button, client creates one unique identifier for that payment request, which is idempotent keys. Along with your request, that idempotent key is actually sent to the server, and then what happens at the server side is that server checks whether that idempotent key is safe into the database or not. Why it actually is checking that idempotent key is present in the database or not, this is something I'll tell you next in the next example. Since this is a fresh request, there is no such entry present in the database, and then server save that idempotent key to the database, and then trigger or initiate a transaction to deduct the amount from your database, from your bank account and then create a transaction ID and send it back to the client. Since there's some network failure or some bad happened during that communication from server back to the client, client is not able to get the response back from the server. And thinking that payment was not successful, client re-trigger or re-initiate the payment and click on the pay button again. So what happens is, because you are just again clicking on the pay button, everything is intact. So idempotent key was actually pre-calculated before you clicked on the pay button. So the idempotent key is same. So when you click on the pay button again, um, client send the same request with that unique and important key to the server, and this is where the check comes into the picture when server actually checks whether that important key present in the database is or not. So client receive the request and check whether that idempotent key present in the database or not, because the previous request was already processed by the server here, and server already saved that particular idempotent key in the database. It When it checks again whether that idempotent key present in the database or not, it's already present. That means it's a duplicate request. So what happens next at the server side is that server understand that it's a duplicate request, and it already triggered one transaction to deduct the amount from your database, from your bank account. It gets the transaction ID of the previous request and send the same transaction ID back to the client, instead of considering this request as a fresh one and deduct the amount again from your bank account. So any subsequent request, the subsequent retry from the client side, the same idempotent key will be sent to the server, and server do the same thing again and will understand whether the request is the retry or not. As a result, only one payment is processed. Client can safely do the retries, thinking mistakenly that the payment was not processed, and duplicate transaction will be avoided at the server side. So thank you so much for watching this video. If you like this video, please give a thumbs up. Bye.